CS4, and in this video I'm going to discuss about HTTP protocol. So let's start. Let's begin with a short introduction about HTTP. So Hypertext Transfer Protocol or HTTP is a protocol, or as you can say it, a standard set of rules which dictates how the fetching of resources such as HTML documents happens. HTTP was designed as a way for communication between web browsers and web servers. Now, in this case, web browsers are treated as clients and web servers are treated as servers serving to the clients. And now, the HTTP protocol is at the backbone of the World Wide Web nowadays. There have been many versions of HTTP, and without it, the smooth delivery of data in World Wide Web cannot be possible. Now, HTTP is a very simple to implement. It is stateless. That means that it does not hold data by by the server between our sessions. However, due to HTTP cookies, it is not sessionless. HTTP is an extensible protocol which has evolved over time. It is an application layer protocol that runs on the top of TCP layer. It runs at the very top of the application layer. So what happens is whenever a client is loaded, it first puts an initial fetch request, and then later the entire web page is loaded. A web page can be said to be a complete document that is reconstructed from different subdocuments fetched. For instance, text, layout descriptions, images, videos, scripts are many such subdocuments which when combined together make a web page as a whole. So the HTTP is behind all the continuous continuous communication between client and server, without which the internet will cease to exist. Now let's discuss about HTTP request in detail. So what is an HTTP request? Well, an HTTP request is a message initiated by client, which is usually a web browser as we have discussed, and this message is sent to the server. This communication is fundamental to how the World Wide Web operates. The primary purpose of the request is to ask the server for a specific resource. Now, this resource can be various things, such as a web page, an image, or a data stored on the server. Now, since in HTTP a client-server communication takes place, so the client is always the initiator. Now, the HTTP request use different methods to indicate the type of action that a client might want to perform on a specified resource. Now, these various methods can vary from get, post, put, delete, head, options, etc. Now, let's briefly discuss these methods in the next slide. So the three most common HTTP request methods are get, post, and put. So what is get? So get refers to retrieving data from the server by the client. Now post. Post refers to the submission of data to be processed to a specific resource. Now put. Put means to update a resource or create a new resource if it does not exist. Now delete means deleting an existing data from server. Now patch means to update a resource but only do it very partially. Now moving on. Now let's take a quick look at the structure of an HTTP request. So here as you can see that a get HTTP request has been made at this particular URL. Now the request is made in HTTP 1.1 version, and in the response we got the HTTP header and HTTP body. Here the HTTP body is empty, and HTTP header, which we are going to discuss in the next slide, contains all the additional information. It contains the host, the encoding, the connection status, and the user agent as well. Now let's discuss about what is a HTTP request header. Well, in the context of HTTP request, headers are additional pieces of information included in the request sent by the client. They are separate from the main body of the request as we saw in the previous slide. They actually provides metadata about the request of the client. Now, some of the examples of HTTP header can include user agent, host, and content types. Now, let's discuss about these three. Now, first of all, what is a user agent? Well, user agent header identifies the client making the request, typically indicating the type of device or browser used. Now the host header specifies the domain name of the server being used. In case where a server hosts multiple domains, this header helps the server route the request to the appropriate website. Now the content type header. Now the content type header indicates the type of data that is being sent in the server. For example, it might specify that the request body contains JSON data or XML data. Now, the header is extremely important with both request and response because it provides us an contextual information which can do a crucial role in order to understand the client's requirement, capabilities, and preferences. It can also help us to customize and optimize the response from the server. Now let's discuss about HTTP response. Well, the HTTP response is the other half of the famous request response cycle employed in HTTP. Well, an HTTP response is the server's counterpart to the client's request. It is it is generated by the server in response to the client's HTTP request. The server creates and sends a response back to the client. Now, this response can contain the requested data or information about the outcome of the request. Now, this information can be in the form of status codes. The HTTP status codes carries the required data or a status code that indicates the outcome of the request. Some of the popular status codes includes 200 or 404. Well, here 200 means that the request is successfully processed, or 404 means that the request resources could not be found on server. Similarly, 500 means that there might be an error in the internal server. Now, this plays a very crucial role in the content delivery since the HTTP request response is fundamental in delivering the requested web content to the client. It is the vehicle through which the server communicates the outcome or the actual data back to the client. However, the completion of the HTTP response marks the end of the request response cycle, with the server fulfilling the client's request. Much like the HTTP request headers, HTTP response headers also provide supplementary information about the response. This information can include details about the content type, which can specify that the type of data sent is either a JSON format or in HTML format or in XML format. Then it can also give the directives about cache control, which can guide how the response should be cached by the client or intermediary caches. Now it can also give us the additional information about the server or what version of the server is using. Now, apart from this, it can also give the client guidance. The response headers play a crucial role in guiding the client on how to process or display the data received on the response. For example, the content type header informs the client about the format of the data, helping in determining how to interpret and display the content to the user. Now, since we have discussed separately about the request and response, let's discuss that how both of these works with hand in hand. So, the request response cycle represents the dynamic and ongoing interaction which happens between a client and a server. This interaction occurs over the HTTP communication protocol. The HTTP protocol was designed to do so. Now, as we have discussed that the cycle starts with client which always initiates the HTTP request. Now, these clients are usually in the form of web browsers, and they do it from user as user agents. Now, in response to these requests, server generates and sends HTTP responses back to the clients. The request response cycle is fundamental to understand how data flows between web browser and web servers. It forms the pieces for communication in web development. This cycle illustrates the back and forth flow of data between client and server, showcasing how information is requested and delivered over the web. Here in this diagram, you can also see that in the server side, we have database and web server, and in the client, we have a browser. So whenever you enter, let's just say google.com, so it sends a request to load to give the client the pages related to that particular URL. So the database communicates with web server and sends the response in the form of HTML, CSS, and JS documents, which are then successfully rendered and shown to the end user who requested that particular URL. Now, throughout history, there have been multiple versions of HTTP. There have been versions from HTTP from 0.9, 1.12 to even HTTP 3 now. So these versions always aim to improve the performance, security enhancements, and efficiency. The HTTP 1.1 version has been widely used and was a significant improvement over the original HTTP 1.0. It introduced features such as persistent connections, pipelining, improved compression, etc. And then after HTTP 1.1, the major improvement was HTTP 2. The major update in HTTP 2 was performance. It introduced features like header compression, multiplexing, prioritizing of requests, aiming to reduce latency as much as possible, enhance the loading speed of web pages, etc. Now, HTTP 3 is also being developed, and it also aims to improve the HTTP protocol in all these three areas. It aims to reduce the latency, optimize resource loading, and improve overall responsiveness. At the same time, also keeping the new and improved security enhancements in mind. Understanding HTTP versions and HTTP is extremely crucial for web developers and web administrators in a very similar way. And with that, we are at the end of the slide, and let us briefly conclude what we have learned in this slide. We have learned about what is HTTP request, HTTP response, headers, and the request response cycle. We have also learned that HTTP is the fundamental backbone of the World Wide Web. It has shaped much of the modern web which we use now and improved its performance and security. Now, with that, thank you for joining me.